starting a free open lecture on Discord. All our lectures are held weekly, without interruptions. If you, viewer, want to ask questions and get answers online, join our lectures. You can find the link to Discord in our Telegram channel. To find out the lecture schedule, join our Telegram channel. Do you have questions about the join function? What's going on here? What exactly is this counter? How do we standardize the profile and repaint it to the needed colors? What's happening here? Zhenya, do you have any specific questions? Well, the counter is clear in principle. Now about normalization once again. Well, look, it's important that the maturation period is found as a single unit. This is important for us to avoid duplicate profiles. We currently have a counter, which is a variable. It is set using the value k. Initially, it is equal to 0. So we have some profiles here that go like this. Do you definitely want to become a cool programmer? Subscribe right to our Telegram channel. Do they absolutely have any crazy numbers here like 2, 2? Here, 3 and 3 are essentially the most important thing for them to just be unique and have a pair, and how they are numbered here doesn't matter at all. Moving on, we go from left to right and encounter the first profile, which is a 2. First of all, each new profile is a +1, which is great. Next, we repaint the 2 into a 1, and we remember that if the color further on is equal to 2, it needs to be changed to 1. We remember this. Using this thing here, we remember that this color, which was originally there, is what it should be. And this is how we pass it to the other end. Next, we proceed forward, and once again encounter a 3. We repaint it twice over. And we remember that if the color is 3, which is a primary color in this context, it needs to be repainted to 2, which is another primary color. Next, we encounter the number 2. For the number 2, we have a specific condition. It should be changed to 1, which is the final primary color in this sequence. Repainting. Next, we encounter a 4, which is significant. The counter will then increase to 3, as expected. And this we will basically repaint and change to 3. Remember that if the encountered or found color is 4, it needs to be essentially changed to 3. Next, we encounter another 3, and we repaint it to 2. And the last thing we will encounter is 4, which needs to be repainted to 3. Now it's clear, right? So we have 2 functions left. This is the slider, but I think it's more or less clear what it does. It repaints all paths from C1 to C2. For example, if we had some transitions like this, it ensures that here and here it does this thing. Accordingly, here we will have, let's say, C2, here C1, and we need to repaint all C1 to C2. This thing happens here, TFSP. If we encounter C1 in array A, we repaint it to C2. If we encounter C1 in array B, we repaint it to C2. This particular thing is absolutely essential when it comes to finding the ends of various paths and numbering them correctly and properly. So, what we have here in this situation is the solver, and this is exactly what's happening in this context. Here, everything will be ready for it. The entire graph will be calculated. We, accordingly, iterate through the rows, starting from the first one. For the 0 row, everything is ready as well. We iterate through the vertices, meaning this is our mask from 0 to 1, and this is from 1 to 2. Well, if we take into consideration all ones, for instance, we check if we have an edge. If it exists, we add what was calculated in the previous profile to the next one. We simply store 2 rows, which is the number of ways to obtain a profile. And the minus first row is on this one, when transitioning, specifically from 1 to it. And when transitioning from I to I plus 1, and then, in order to continue storing only 2 arrays, we pass what was, the next profile will become the previous one, and the next will be 0. And then we simply sum the function f0, which represents the initial function, into the answer. In the specific case when there is a graph present, that is, when there is an edge connecting the nodes, and also at the end here we will multiply by 2 because we have a mirrored profile, meaning from top to bottom you can also go just like from bottom to top. We will multiply all these things here. So that's it. We've gone through all the code here. Want to become a cool programmer? Subscribe to our Telegram channel